Hey Nicholas, welcome to part two. I'm going to be getting into the airport a little bit late, so I was going to end up having to start class late, but I figured maybe we'll just go ahead and do another video. And since today's mostly going to be a quiz, then, I'll just go over some basic stuff and then lay out the quiz for you for class, okay? So, first thing is, I actually have made a mistake with my calculations. I just noticed this yesterday. But when I did b over 2a squared, I had just wrote b squared over 4a. I forgot to square this down there. And that's what was actually leading to my derivation not working right. So, made a mistake there. That should actually be divided by 4a squared, right? Because you got to square the 2 and the a, 4a squared. So once you have that, then you end up having it look like this, right? Negative c over a plus b over 2a squared. If you square that, you get this. Over here on the left, if I want to make a common denominator, well, 4a squared and a, what's the common denominator? 4a squared. So I need to multiply this times 4a over 4a, so I can make that a 4a squared. And remember, I can do this because 4a divided by 4a is just 1. So I'm not actually changing anything, I'm just making it look more convenient so I can combine these fractions. Right? This is no different than if I have something like 1/3 plus, 1/9, right? I would just multiply this times 3 over 3 so that I can make this a 9, and now it's 3/9 plus 1/9, and I can get 4/9, right? So I just need a common denominator so I can go ahead and combine these two fractions. Same exact thing over here. I want to combine this c over a with that b squared over 4a squared. So I multiply by 4a over 4a. Well, that gives me 4ac negative 4ac plus b squared. Or I can flip it around and say b squared minus 4ac. And all of this is over this common denominator of 4a squared. Awesome. So now once I get to this point, as I wrote down there, I'm going to take this 4a squared. This is a perfect square. 4 is a perfect square. A squared is a perfect square. I can go ahead and take these out of the root. So what's the square root of 4a squared? Just 2a. But it's still going to be in the denominator. So I'm still going to have my negative b over 2a plus or minus the square root of b squared minus 4ac. But this is going to be divided by 2a that's outside of the root because I've already taken the square root of that. And at this point, oh, by the way, remember this all equals x, right? And at this point, well, what do I notice? Denominator of 2a, denominator of 2a, I can go ahead and combine these fractions as well. And that'll give me my final version of quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, that's all of this, divided by 2a. Remember, this is what x equals. And so this lovely thing here is quadratic formula. By using completing the square on the general form, the ax squared plus bx plus c equals 0, we completed the square and created this formula so that we could solve any quadratic equation. It's a pretty powerful idea. Now, there's some points that I wanted to mention to you that are worth thinking about. So, in your homework, you actually mentioned at one point that you can't square root a negative number when you try to get one of these solutions. And that's a very interesting thing because if you think about it, there's a few things that could happen under the square root, right? This b squared minus 4ac term is very special. We actually have a name for it. It's called the discriminant. And the way I like to think about discriminant is it sounds like discriminate, right? Which is usually a pretty negative term, but the base meaning of discriminate is, right, if you want to discriminate between two things, it's really to kind of tell the difference between them, right? To be able to understand the difference between one thing or another. So in math, the discriminant allows us to see what type of quadratic that we're dealing with. If this term is greater than 0, right? I'm going to say if the discriminant is greater than 0, then when you take the square root of a positive number, right, greater than 0 means you're positive. When you take the discriminant, or the square root of a positive number, you get another positive number. Why is that important? Well, that means you're going to get b, negative b plus or minus a number over 2a. That means you're going to have two answers. You're going to have negative b plus the number, and you're going to have negative b minus the number over 2a. So when d is greater than 0, you're going to get two solutions. Right? You're going to get the plus version and the minus version of negative b and all the other junk. But what's the other situation? What about if d is equal to 0? Well, if d is equal to 0, the square root of 0 is just 0. Plusing 0 and minusing 0 still gives you the same thing. Your answer just basically becomes negative b over 2a. Well, that's just one single solution. So that's another situation that we can have. So when the discriminant is equal to 0, we actually just have one solution. And finally, when the discriminant is less than 0, when it's negative, you can't take the square root of a negative, so you have no real solutions. And so it's kind of cool we came up with this formula, but we can also understand the nature of the quadratic right away just by computing this b squared minus 4ac. If it's positive, two solutions. If it's 0, one solution. If it's negative, no solutions, no real solutions. So we can get into imaginary numbers and all that stuff, but real solutions, if it's less than 0, not going to work, right? You can't take the square root of a negative number and get a real number. And so that's it. That's how you derive quadratic formula. They did a really good job of writing it nice and neat and compactly over here, so I'm guessing you got a chance to look at that. So why don't we go ahead and look over your homework, and then I'll give you the quiz. Okay, so let's look at this first one here. Again, x squared minus 9x plus 18 equals 0, right? So first off, I'm going to write what a, b, and c are, right? So a equals 1, b is negative 9, and c is 18. So now I just plug it into my formula. Negative b plus or minus the square root of b squared minus 4ac over 2a, those are my solutions, right? So if I plug this in, I'm going to get x equals, well, negative 9, right? Negative b is positive 9, plus or minus the square root of b squared, well, that's negative 9 squared is 81, minus 4 times a, which is 1, times c, which is 18. 4 times 18 is 72. So minus 72. All divided by 2 times a, which is 2 times 1, which is just 2. 81 minus 72 is 9. Square root of 9 is 3. So we get 9 plus or minus 3 over 2, which is just 9 plus 3 over 2. That's 12 over 2 is 6. Or 9 minus 3, which is 6 over 2, which is 3. So the two solutions here should have been 6 or 3, right? And we could have also just factored this normally, right? Because what are the factors of 18 that add up to 9? Well, negative 6, negative 3, so it's just x minus 6, x minus 3 equals 0. My solutions are x equals 6 or x equals 3. All right, so just double check your work on that. Maybe there was like a little typo or something with the formula, but hopefully that makes sense. So let's go over here and check out number 2. So same deal, right? Just write my A, B, and C. A is 1, B is 5, C is 4. Plug them into the formula. Negative B plus or minus the square root of B squared minus 4 times A times C. Well, 4 times 1 times 4 is 16. All divided by 2 times A, which is just 2. 25 minus 16 is, again, 9. Square root of 9 is 3. So negative 5 plus or minus 3 over 2 gives us negative 5 plus 3 is negative 2. Divided by 2 is negative 1. Or negative 5 minus 3 is negative 8. divided by 2 is negative 4. And looking here, it looks like you got that correct, so awesome. Great job. Let's go to number 3. Same exact process. N squared minus 64. Looking at these numbers, right, you always want to do a check on your numbers too, Nicolas, right? So something squared minus 64 is 0. Well, 2,000 something squared is going to be some huge number, right? Like 4 million something. If you just subtract 64, you're probably not going to get to 0. So whenever you get your answers, you also want to kind of do what I call it a gut check. Where you say, oh, does that look right? Does that feel right? You know, or worst case scenario, just actually plug it in and see if it works, right? So we can tell that there's something a little off about these answers, but let's try to solve it. Same thing as before, write down our A, B, and C. A is 1. B is actually 0. There's no n term. And C is negative 64. And then we plug into our formula. Negative B, well, that's just 0. Plus or minus the square root of B squared, well, that's 0. Minus 4 times A times C. Well, 4 times 1 is 4. And then 4 times 64 is 256. So then we have, this is negative, so it's going to be positive 256. All divided by 2A, which is 2 times 1, so just 2. 0 plus 256 is just 256. Square root of 256 is 16. So this is all 16. And so 0 plus minus, just get rid of the 0, just plus or minus 16 over 2. That means our answer is either positive 16 over 2, which is 8, or negative 16 over 2, which is negative 8. So those will be our two solutions for that one. Hope that makes sense. And then finally, we have number, oh, by the way, you can also notice that this is a difference of squares, right? N squared minus 64 is 8 squared. And how do we do difference of squares? Well, anytime you have a squared minus b squared, it always turns into a plus b times a minus b. Well, if this is n squared minus 8 squared, it would factor to n plus 8 and minus 8. What are our solutions? Plus or minus 8, like we saw down here, right? So you can also check by using other methods, like difference of squares or things like that. Okay, let's look at number 4. So we have b squared plus 5b equals 0. Same thing as before, right? You just find your a, b, and c. A is 1, b is 5, c is 0, right? There's no extra term over here. So plug it into our formula, negative b plus or minus the square root of b squared minus 4 times a times c, but c is 0, so it's just going to, knock out that term, right? Divided by 2 times a, which is just divided by 2. Square root of 25 is just 5. So we have negative 5 plus or minus 5 over 0. Well, negative 5 plus 5 is 0. So 0 over 2 is 0. Or negative 5 minus 5 is negative 10. Negative 10 over 2 is negative 5. So those are our two solutions, 0 or negative 5. Same thing, right? When you get these solutions, you want to just double check them and make sure that everything checks out. Because I think maybe there was something going on with your A and your B maybe, or your C. They gave you this root 21 over 2 part. But just check your work. And what's more important than getting the right answer is getting a good process. So I want you to be able to look back at your work and figure out, okay, well, this is where I went wrong, or okay, this is where I made a mistake. Because that's really what's going to be the most valuable thing. And then looking at number 5, we would just do the exact same process, right? Find our A, our B, and our A, our B, and our C. So let me minimize this a little bit to get some room. That's for number 3. And this is for number 1. So there we go. Number 1. Number 3. Alright, and I'll pop on the next video and we'll go over number 5. Yeah, talk to you in a second.